We're in section 7-4, 7.4, and this is part 2. So I'm starting with problem number 16, and I'm gonna figure out that f prime of s is equal to the Laplace transform of minus t f of t. And then with a little bit of manipulation, we're going to find that the second derivative of f of s is equal to t squared f of t. Okay, so our problem states that we want to find the Laplace transform of t squared cosine 2t. So if that's the case, we're going to say that well, we're going to change this a little. We're going to say g of t is equal to that. Okay, excellent. So f of t is going to be equal to cosine 2t, and if I take the Laplace transform of that, I get s over s squared plus 4. And then I want to take the second derivative with respect to s of s over s squared plus 4. And when I do that, I'm going to get 2s s cubed minus 12 divided by s squared plus 4 quantity cubed. Okay, so the Laplace transform of t squared cosine 2t is going to equal 2s s cubed minus 12 divided by s squared plus 4, the quantity cubed. Isn't that convenient? Write that down on your Laplace transform table, so if you need it again, you'll have it. Number 20, we have f of t is equal to 1 minus cosine 2t divided by t, and we want to find the Laplace transform of f of t. Okay. So, we could say that the Laplace transform of 1 minus cosine 7 cosine 2t. Cosine 2t divided by t is going to be equal to the integral s to infinity of f of sigma d sigma. Okay, so we could do that, and we could say, well, if g of t is equal to 1 plus cosine 2t, then the Laplace transform of g of t is going to be 4 over s squared plus 4. Okay, so the Laplace transform of 1 minus cosine 2t over t is going to equal integral 0 to infinity 4 over sigma squared plus 4 d sigma. Okay, and with that we'll have to do partial fractions, but we know what the partial fraction is going to be, I think. I don't know, maybe we do. Okay, so if we take a sigma over b sigma plus c over sigma squared plus 4. If we do that, then we're going to get that 4 has to equal A sigma squared plus 4A plus B sigma squared plus C sigma. And if we look at the sigma squared term, we have A plus B is 0. We look at the sigma term and we get C is equal to 0. And we look at the unit term and we get A, 4A is equal to 4, which implies very strongly that A is equal to 1. If A is equal to 1, then B is equal to minus 1. And then what we end up with is integral s to infinity of 1 over sigma plus minus 1 over, that's a b, right? B is minus 1, so 1 sigma over sigma squared plus 4 d sigma. Okay, well, that's going to be, and we're going to do the limit b goes to infinity and make this a b up here. So that'll make everything a little bit better. So limit b goes to infinity of natural log sigma minus 1/2 natural log sigma squared plus 4 evaluated at s and b. Okay, so we're going to have limit b goes to infinity. I'm going to have limit natural log b minus 1/2 natural log b squared plus 4 minus natural log s minus 1/2 natural log s squared plus 4. And so as b goes to infinity, these two guys cancel each other out. Boom, boom. And we end up with minus natural log s plus natural log square root of s squared plus 4. And that becomes my, what am I looking for? My f of s. So I found the Laplace transform of quantity 1 minus cosine 2t divided by t. And that is it. And what's even worse is that this checks with back of book. So that's even worse. Or that's better, I guess. I don't know. Is that better? Number 22. I have f of t is equal to e of t minus e t over t. Okay? So I'm going to look at Laplace transform of e of t over t minus e of minus t over t. And I'm going to let f of t be e to the t and g of t equal e to the minus t over t. Okay, and then I'm going to go and take the integral s to infinity of f of sigma minus g of sigma d sigma. I'm going to go back and get rid of these t's. Alright, so I got rid of those t's. Okay, that's good. So now I'm going to have limit b goes to infinity, interval s to infinity, 1 over sigma minus 1 over sigma plus 1 d sigma. Okay, and then I'm going to have limit b goes to infinity, natural log sigma minus 1 minus natural log sigma plus 1 evaluated at s and b. Okay, so I'm going to have limit b goes to infinity, natural log b minus 1 minus natural log b plus 1 minus natural log s minus 1 minus natural log s plus 1. As I go to infinity, these two cancel each other out, and I end up with a final answer for f of the Laplace transform of f of t as being natural log s plus 1 minus natural log s minus 1, or we could rewrite that as natural log s plus 1 divided by s minus 1. That would be the same thing, and that would be a check with backup book. There's 22. Now we're going to do 22 one more time. Going to do 22 again. Number 22 again. Okay, and so we have e to the t minus e to the minus t over t, and we recognize that as 2 hyperbolic sine t over t. Okay, so we're going to go and say that 2, the Laplace transform of hyperbolic sine t over t is going to equal to the integral s to infinity of k over, there's a k sitting there, sigma squared minus k squared d sigma. Okay, so that's what we're going to do, and we have 2, well, we'll go with limit. Limit b goes to infinity, 2 integral 0 to infinity, 0 to b, 1 over sigma squared minus 1 d sigma. There is no k. There is no k. K is 1. So this is a 1, and this is a 1, and this is a 1. 1, 1. Okay. D sigma. Okay, well, we can put the k back in. Doesn't matter, because we know k is 1. Alright, well, that being the case, then this is going to be limit b goes to infinity of minus a half times 2 times limit sigma plus 1 divided by sigma minus 1 evaluated at s and b. Okay, so I put in b and I go to infinity, and that's going to be the natural log of 1, which is 0. So this is going to be 0. And then I've got minus, and then I've got minus again for the s guy, which makes it plus natural log s plus 1 over s minus 1. I think. Is that what we had before? S plus 1 over s minus 1. Yep. We were just plain lucky, I guess. Okay, 24. Number 24. F of s is natural log s squared plus 1 over s squared plus 4. And what we want to do is find f of t. Okay, so f of s is natural log s squared plus 1 minus natural log s squared plus 4. The first derivative is going to be 2s over s squared plus 1 minus 2s over s squared plus 4. Okay, and minus the Laplace transform of minus t f of t equals that f prime of s, which is equal to the stuff over here. So if I take the reverse Laplace transform of everything, then I'm going to have minus t f of t is equal to 2 cosine t, 2 cosine t minus 2 cosine 2t. And then I bring the f of the minus t on the other side, f of t. Final answer, f of t is going to be 2 cosine 2t minus 2 cosine t divided by t. And I won't even look in the back of the book for that, because there's no reason to think it's anything other than that. T. Okay, 26. Number 26. I have f of s is equal to the arctangent of 3 over s plus 2. Isn't that lovely? F prime of s is equal to 1 over 1 plus 3 over s plus 2, the quantity squared. And the inverse Laplace, the Laplace transform from minus t, f of t is equal to that first derivative. Okay, so we're going to take the an inverse Laplace transform of all that we see, and we're going to have minus t f of t is equal to well, we know that that was wrong, don't we? All right, let's move back a little bit. F prime of S. Okay. F, change colors, F prime of S is going to be minus 3 over x plus 2, the quantity squared, times 1 plus 9 over s plus s squared plus 2, the quantity squared. Okay, that looks better. Okay, this is going to equal minus 3 over x plus 2, the quantity squared, plus 9. Okay, and we're going to rewrite that a little bit. And then we're going to say, well, we won't. We'll say f of t is going to equal minus 1 over t inverse Laplace transform of minus 3 x plus 2 cubed plus 9. Okay. And the minus sign is going to come out and cancel out that minus sign. And f of t is equal to 1 over t inverse Laplace transform of 3 x squared plus 2, the quantity squared, plus 9. I'm pretty sure I said squared. How come I put a 3 there? Okay. Now we go looking for that reverse Laplace transform. And somewhere I put my table. So I've got that looks like number 9. Okay, so this guy looks like number 9. And when I do that reverse Laplace transform, I got f of t, final answer, equals 1 over t, e to the 2t, minus 2t, e to the minus 2t sine 3t. And that checks with backup book. Okay, we're going to do 28 next. F of s is s over s squared plus 1 cubed. Okay, the Laplace transform of f of t divided by t is equal to integral s to infinity f sigma d sigma. Okay. So we need the okay. So I look at this and I say, well, if I had a minus 4 there, then it would be easier to integrate. If I had a minus 4 up here, it'd be easier to integrate. So I'm going to say this is equal to minus 1 over 4, limit, b goes to infinity, integral s to infinity of minus 4 sigma over s squared plus 1 cubed d sigma. Okay, and I'm going to get minus 1/4, limit b goes to infinity of 1 over s squared plus 1, the quantity squared, okay, evaluated at s and b. Okay, minus 1/4, limit b goes to infinity, 1 over b squared plus 1 squared, which goes to 0, minus 1 over s squared plus 1, the quantity squared. Okay, so I'm going to end up with the Laplace transform of f of t over t is going to equal minus and minus, so it's going to be 1/4 over s squared plus 1, the quantity squared. Okay, and we look at our Laplace transform and we see we have something s squared plus 1, the quantity squared, s squared plus 1, the quantity squared, looks like number 18, looks like number 20, s squared plus 1 quantity squared, looks like number 20. Okay, so we're going to use number 20 and take the inverse Laplace transform of everything, and we're going to say f of t over t is going to equal 1/8 sine t minus t cosine t. Oh, we're skipping a step. Why are we skipping that step for? Is equal to 1/8 no, we're not skipping. No, we're not skipping any steps. No, I'm perfectly okay. Sine t minus t cosine t. And when we put the t on the other side, we had f of t is equal to t over 8 sine t minus t squared over 8 cosine t, which checks with back of book. Okay, so now we're going to add a little bit of theory and say that the Laplace transform of x of t, is going to be minus x prime of s. The Laplace transform this is a t x of t. The Laplace transform of t, first derivative f of t, is going to be equal to minus f of s plus s first derivative of s. And the Laplace transform of t, second derivative of f of t, is going to equal minus 2s f of s minus s plus s squared f prime of s minus f of 0. Okay, so that's from section 4.4. And now we're going to work a problem, number 30. Going to hope for the best. We have t x double prime plus 3t minus 1 x prime plus 3x is equal to 0. Okay. Okay. All right. So now we're going to apply our newly gained rules. And we want to take the Laplace transform of that. Okay, we're going to have minus s squared x prime of s minus 2 s of x. I'm going to look at the book real quick for the number 3 problem, problem number 30. So x at 0 is 0. That's what I was hoping for. X at 0 is 0. So the x at 0 is 0, so we don't have to write down. Okay. Then I've got minus 3 x of s minus 3 s x prime at s minus s x of s plus 3x of s is equal to 0. Okay, then we're going to have minus s squared minus 3s x prime at s minus 3 s x 0 s x minus 3s x of s is equal to 0. I wonder how I got that. Okay, there's the prime term. There's the prime term. I see that. Minus 2, minus 3 plus 3. They go away. And that'd be minus 3. Okay, so that would be okay. So I've got that x prime of s is equal to 3s divided by s squared plus 3s x of s, which is equal to 0. Okay, so I've got the derivative of x of s with respect to s is equal to minus 3s over s squared plus 3s x of s. Okay. Okay, that's good. Now we're going to do chapter 1 things and separate variables. So d x of s divided by x of s is equal to minus 3s s squared plus 3s ds. Isn't that lovely? We're going to integrate both sides. And we're going to get natural log x of s is equal to minus the integral of 3 over s plus 3 ds. Okay, that's going to be natural log x of s is equal to minus 3 natural log s plus 3 plus some constant c. Okay. If I use these things as powers of e, if I do that, then I can have x of s is equal to some constant c s plus 3 raised to the minus 3. Okay, so x of s is equal to some constant c over s plus 3 cubed. And by our Laplace Transform table number 16, I think, number 16, 1 over x, yes, that's the right run. X of t, when I take the inverse Laplace transform of both sides, I'm going to have that x of t is equal to c t squared e to the minus 3t divided by 2. Now, isn't that beautiful? Oh, and it checks with back of book too. That's back of book, it checks. Okay, with that we are done with chapter 7 section 7-4.